In this example, we're going to look at the ionic bonding between sodium and oxygen. So sodium, as we already know, is a group 1 alkali metal. Oxygen is a group 6 non-metal. So in order to react, they both want to obtain their lovely stable outer shell. So all sodium has to do is lose 1 electron to reveal the full outer shell underneath. Oxygen, however, has only got 6 electrons in its outer shell. It needs to obtain 2 electrons, but sodium only has 1. So to get round this, the oxygen will actually react with 2 sodium atoms instead of 1. So each sodium will donate a negatively charged electron to the oxygen. The oxygen will then obtain its full outer shell, and the sodiums will lose their original outer shell to reveal their lovely stable full outer shell underneath. So if we were going to show this, we would have our oxygen. So let's do oxygen first. Now has its lovely full outer shell. I'm going to stick with the colours just for now. Now, because the oxygen has gained 2 negative electrons, it has 2 negative electrons more than it has its positive protons in the nucleus, so it gains a charge of 2 minus. With the sodiums, we would have 1 sodium here, so if we deal with that sodium first, it has lost a negative electron, so it now has 1 proton in its nucleus more than it has electrons, so it gains a charge of +1, but we'll just show it as a plus. And here's my other sodium, same thing applies. Okay, so there, and the electrostatic attraction between the negative and positive charges forms a very strong bond. So if we were going to look at the symbol equation for that, we have sodium plus oxygen. Now what we've got to remember is that oxygen is diatomic, so would occur as a 2. We are going to have sodium 2, apologies, just going off there, oxide, because our 2 sodiums have to react with 1 oxygen. So in order to balance that equation, if I have 2 oxygens here, I must have 2 oxygens on this side. So the only way to do that is to have 2 sodium oxides. I now have 4 sodiums here, so I have to have 4 sodiums there, and that is my lovely balanced equation.